All right, this is Unit 3, Lesson 1. Ready, set, let's go. Okay, let's graph this thing. Notice we have an output value of f of x and an input value of x. So I'm going to make a table of values. I'm going to let x be these values, and I'm going to plug them in one at a time. That's how you find the output, right? Pick an input, substitute it in, that's the output. So negative 2 times negative 1 plus 5, 7. Now if I do that same thing with 0, I get 5. Do the same thing with 1, I get 3. I'm now going to draw my coordinate plane. There's my x-axis, and there is my, oh geez, Rick, there's my f of x axis. All right, let's plot some points. So negative 1, 7, 1, 2, 3, 4, 5, 6, 7, 0, 5, 1, 2, 3, 4, 5, and 1, 3. 1, 3. Sorry about that. Y-axis is crazy. I don't even know if that's, accurate, but I think you get it. So that's the graph. Let's find the solutions, the 3 solutions. These are the 3 solutions, right? I made a table of 3 input and output values. So those are the solutions. There's an infinite number of them. This is just 3 of the infinite number of them. That is linear. Notice how minus 2, minus 2. That's because that is our common sum or difference. And notice also our initial amount at 5, right? Boom. Okay, so let's go here. Again, I'm going to do really the same thing. I'm going to draw my x-axis. But notice I'm going to label my y-axis differently. I'm now going to label my y-axis g of x. Let's make a table of values, x, g of x. All right, I'm going to put in negative 1, 0, 1. So I'm going to go here. I'm going to go 4 minus 3 times negative 1. Notice how I use the subtraction and the negative properly. That gives me 7. If I put in 0, and if I put in 1. Notice your initial amount 4, boom. Notice your common sum or difference is negative 3. Subtract 3, subtract 3. So we're good. Negative 1, 7, 1, 2, 3, 4, 5, 6, 0, 4, and 1, 1. Draw your line. Remember, these are the solutions, these 3 values in the table. So this is negative 1, 7, this is 0, 4, this is 1, 1. And that is done. Those are linear, so common sum, common difference. This is exponential. When I have exponentials, I tend to put my x-axis down here, because most of the exponential functions are going to happen above the x-axis. This is x. These coordinate planes are getting better. I like that. And this is my h of x, the output. All right, let's make a table of values. X, h of x, negative 1, 0, 1, 2. Let's put in negative 1. Actually, well, I'll do it on the next one. Let's put negative 1 in. 5 times 1 divided by 2, exponent negative 1. That's 10. 0 is going to give me 5. I know that because that's my initial amount. Exponent of 1 is going to give me 2.5. Notice how we're decreasing by a half, decreasing by a half. Let's decrease by a half, right? Because that's that common multiplier right there. That's that common multiplier. 10 times a half, 5. 5 times a half, 2.5. 2.5 times a half, 1.25. Negative 110, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, 5, 1, 2, 3, 4, 1, 2.5, that's 2 and a half, 2, 1.25, right there. Now let's draw that curve. That's a pretty good graph. We need 3 solutions. That's a solution. Remember, solutions for the coordinate plane look like ordered pairs. So if I ask you for a solution, and you have a 2-variable equation, right, x and y, then your answers are ordered pairs. All right, this is also exponential. So I'm going to go ahead and do this one as well. I'm going to go with my x-axis way down here. And then my k of x-axis is going to be right in the middle. Boom. All right, now I'm going to do this one differently. So what I know here is this is my initial amount. So that's 0, 4. Right? So 0, 1, 2, 3, 4. That's my multiplier. So my multiplier is 2. So I know that 0, 4, 1 multiplied by 2, 2 multiplied by 2, negative 1 divide by 2. So it's nice to be able to make a table like that when you identify exponential, linear, and how the pattern works. I'm going to go ahead and do these 3 solutions real quick. And then I'm going to plot those points. Negative 1 dose, 1, 8. And we're not going to do 2, 16 because it's out of our window for our coordinate plane. So boom, boom, and you is done. Number 5, this is going well, this is going well. All right, this is also linear. This is also linear. This is x. This is, sorry, it's t. Should have looked closer. And v of t. So they changed my input variable on me. Let's make a table of values. T and v of t. I'm going to put in negative 1, 0, 1 because it's linear. 0 is easy because that's my initial amount. Negative 1 is going to give me negative 6.5 when I substitute negative 1 in for t. 1 is going to give me negative 1.5. So negative 1, 1, 2, 3, 4, 5, 6 and a half. Ooh, it's negative though. I went the wrong way. Negative 1. 1, 2, 3, 4, 5, 6 and a half. 0, negative 4. 1, 2, 3, 4. 1, negative 1.5. Boom. Draw your graph. I lost my ruler. I found it. I put it underneath my book. Oh my gosh, now I can't pick it up. I got it. We're good. Woo! And that is that. Okay, now let's go to this exponential. I'm going to do this exponential the way I did the other one because I think exponentials, if you can identify the initial amount, that's 2. And then your multiplier is 3. 2 times 3, 6. 6 times 3, 18. Go backwards and you divide by 3, which is that. Okay? So I'll write these as my solutions. 0, 2, 1, 6, 2, 18. Draw your coordinate plane. That is x, sorry, and f of x. I had to make sure I identified my input and output variables correctly. Ooh, I'm awfully crooked on these things. F of x. I'll get better, I'll get better. 0, 2, 1, 2, 1, 6, negative 1, and about 2/3. And this graph goes like that. Woo, that is done. Okay, let's move on. Okay, looks like we got some match each given graph to one of the following contextual descriptions. So these are the contextual descriptions. Then label the independent and dependent variable. Okay, I got to remember to do this part. On the axis. Okay, I got this. All right, so the amount of money in a savings account where regular deposits and some withdrawals are made. That is not that, because this jumps, so it's going to be more like this. But these are just withdrawals. There's no deposits, right, because it's going down the whole way. So that's not it. The temperature of an oven on a day when mom's baking several batch of cookies. I think that's it, right? So oven is preheat oven, boom, boom, boom. Put the cookies are in. They cook. You open up the door, pull the cookies out. Oven has to heat up. Cookies in, cook. Pull the cookies out, blah, blah, blah. So this is B. Temperature in an oven. Time is always horizontal. So this is going to be time. And this is going to be oven temperature. Time is always your x-axis, all right? All right, let's take a look at this one. Contextual description. It's increasing all the time. So it's not amount of money, because that's going to be more like a step function like this. The amount of gasoline on hand at a gas station before a tanker truck delivers more. Okay, that should be a decreasing function. This is not decreasing. Watermelons are delivered. No, because watermelons are discrete, so it's going to be more like this. The amount of mileage recorded on an odometer delivery truck. Yes. So notice how time goes on, the mileage increases. So that's E. All right, this one, it's either going to be A or D, because this is continuous. These are not continuous. Watermelons are delivered to a farmer's market every Saturday morning. The number of watermelons available for sale on Thursday. I think that's definitely D. All right, those are the watermelons. So this is time of day. This is time again. And then this is number of watermelons, or just watermelons. Right down. Okay. Oh, geez, you couldn't even see it, Rick. All right, there it is. Let's go here. So now we're talking about money, amount of money in the savings account, or amount of gasoline on hand. Okay. One of them is continuous. One of them is discrete. This is clearly the amount of money in a savings account. So that was A, the very first one. And then this is days. And this is money. All right, the last one is the amount of gasoline on hand at the gas station, right? Notice how that's decreasing. So that is going to be C. And we have days again. And gasoline. And it's gallons of gasoline, right? All right, that's it. That's not bad. Okay, let's go on to number 12 and 13. Given a pair of graphs on each coordinate grid, create a list of similarities the two graphs share. Okay, so we have similarities that the two graphs share and differences. Okay, so and differences. Consider attributes such as, so they're giving me a list of things to look at, which is nice. So these are the things I'm going to look at. Continuous, discrete, increasing, decreasing, linear, exponential, restrictions on domain and range. Okay, let's talk about it. So number 12, similarities. All right, so I'm going to go here. I'm going to go similar. Okay, so what's similar? Well, they both decrease because they're going down. So decrease. And they're both continuous. And they are They have the same domain, all real numbers, right? Okay, good. Now let's talk about differences. Okay, so let's talk about differences. Okay, well, one of them's linear and the other one's exponential. So linear, one is linear and one is exponential. Their ranges are different. Who are they? Maybe not. I'm not going to say that. I'm not sure that that's true. They have different x and y intercepts. So the x-intercepts are different, and the y-intercept is different. Okay? That looks good. All right, let's go to number 13. Similar. And difference. Okay, well, one thing about difference is right away I can say one is continuous and one is discontinuous. Versus discontinuous. Versus discontinuous. Okay? Similarity, they're both linear. Similarity, well, difference, x-intercept and y-intercept are different. I think their domains are also different. Something as similar as they're both increasing. Sorry, I had to look at that for a minute. Notice how they're going up from left to right. Okay, I think that's pretty good. All right, let's talk about the next ones. Let's talk about the go. All right, for each of the equations, solve for x. Okay, so let's do this. I need to have an exponent on 10 that's going to give me 100,000. So I'm going to do 10 exponent 3. That's 1,000. 10 exponent 4. That's 10,000. 10 exponent 5. That's 100,000. So x equals 5. So when you get to these exponentials, you got to just kind of guess and check, right? Notice here, though, we can solve that. Inverse operations. So I'm going to do the inverse of plus 5x. I always like my variables on the left and constants on the right. So negative 2x plus 7 equals negative 21. Subtract 7, subtract 7. So you have negative 2x equals negative 28. Divide by negative 2. You got to do these inverse operations. You got to know how to do these. This is middle school. So you have to know how to do it. If you don't know how to do it, you need to go to Khan Academy and you need to practice, because we're assuming you know how to do this when you get to this math class. Right here, same thing. It's very similar. Subtract 4x. That's negative 10x minus 15 equals 35. Add 15 to both sides. Negative 10x equals 50. Divide by negative 10, x equals negative 5. All right, let's do this one. Add 8 to both sides. So I'm isolating the term with x. Divide by 5. Boom, you're done. Here's one of those guess and checks because it's exponential. So 3 exponent 2. Nope. 3 exponent 3. 3 exponent 3. Nope. 3 exponent 4. Yep, there it is. X equals 4. And the last one is add 4 to both sides. 4x. Get your x's on the left. Add 12 to both sides. 39? 35. Divide by 7. Boom. All right, good job, kiddos. Stay strong. We got a lot to do before winter break. So you got to be here. You got to be focused. You got to get this job done if you want to succeed in your life. All right. Stay strong. See ya. Bye.